Scientists took a photo of our galaxy, but something doesn't add up. Not with the camera, not with the data, not with the scientists who took it. Some of the most credentialed astronomers on the planet operating an instrument that required the coordination of 8 telescope sites on 4 continents, 5 years of data processing, and a computational effort that produced more data than any radio astronomy project in history. Something is wrong with what the photograph shows. In May 2022, the Event Horizon Telescope collaboration released the first image ever taken of the object at the center of our galaxy, a glowing orange ring surrounding a dark central shadow. The object that anchors the entire Milky Way, the gravitational heart around which our Sun and hundreds of billions of other stars slowly orbit, the thing we have been trying to see for 50 years. We called it a black hole. We printed it on the front page of every major newspaper in the world, and then the physicists started looking more carefully at what the image actually confirmed and what it did not. This problem nobody said out loud. The shadow in the photograph, the dark circular region at the center of the glowing ring, is not proof of a black hole. This is not a fringe idea. This is not contrarian science. This is what the physics actually says when you read past the press release. Any sufficiently massive and compact object surrounded by superheated gas will produce a photon ring and a dark central shadow. Not just black holes, any object dense enough to bend the light that severely. A black hole produces this appearance, but so does a boson star, so does a gravastar, so does a Fermion ball, so does a naked singularity. The photograph tells us what the object looks like from the outside. It tells us nothing about what is inside, and what is inside is the only thing that determines whether this is actually a black hole or something stranger, something that would overturn our understanding of dark matter, dark energy, and the fundamental nature of gravity simultaneously. Think about what that means. We have an image of the most studied object at the center of our own galaxy. We name scientists with the Nobel Prize for proving something enormous sits there. We built a planet-sized telescope to photograph it, and we still do not know what it is. Here is what the evidence genuinely establishes. Something with 4 million times the mass of our Sun sits at the center of the Milky Way, compressed into a region smaller than the orbit of Mercury. We know this because of a star called S2. S2 orbits the galactic center in 16 years. At its closest point, it moves at 7,650 kilometers per second, nearly 3% of the speed of light, just 120 astronomical units from the central object. That speed at that distance can only be produced by one thing: 4 million solar masses in a very small space. The Nobel Prize in Physics 2020 was awarded to Reinhard Genzel and Andrea Ghez for proving this through decades of stellar orbit measurements. But notice what the Nobel citation actually said: not black hole. Supermassive compact object, the most prestigious scientific prize on Earth, awarded by people who choose their language with extraordinary precision, described the most famous object at the center of our galaxy as a supermassive compact object, because that is what the evidence proved, not a black hole, something with 4 million solar masses in a very small space. The distinction matters more than it might seem. There are 4 serious alternatives to a black hole that would produce the same photograph, the same stellar orbits, the same radio emission signature. All of them discussed in peer-reviewed journals, none of them dismissed by the mainstream physics community. The first is a boson star, not made of neutrons or protons or electrons, the ordinary matter of which everything you have ever touched is composed, made of bosons, a class of quantum particle that includes photons and Higgs bosons and several hypothetical particles predicted by extensions of the Standard Model. Bosons can stack on top of each other in ways that ordinary matter cannot. They are not subject to the Pauli exclusion principle that prevents two ordinary matter particles from occupying the same quantum state simultaneously. The result is an object that can be extraordinarily compact and extraordinarily massive without having an event horizon or a singularity. A 2023 paper by an international research team simulated what a boson star with 4 million solar masses would look like to the Event Horizon Telescope. The simulated image was indistinguishable from the actual photograph. The second alternative is a gravastar, gravitational vacuum condensate star, proposed by physicists Pavel Mazur and Emil Motola. A gravastar replaces the black hole interior with a region of dark energy, the same dark energy we covered on this channel, the mysterious force making up 68% of the universe and driving its accelerating expansion. The exterior of a gravastar is identical to the exterior of a black hole. The stellar orbits around it are identical. The photograph it produces is identical. You cannot tell them apart from the outside. The third is a Fermion ball, a dense clump of dark matter particles held up by quantum pressure. The same dark matter we covered on this channel, making up 85% of all matter, never directly detected. If dark matter is made of a specific type of particle called sterile neutrinos, and if those neutrinos have a specific mass, they could clump together into an object at the galactic center that produces exactly the observations we see. This single possibility would simultaneously identify dark matter, one of the deepest unsolved problems in physics, and explain the galactic center. The fourth is something that most physicists consider unlikely, but that general relativity technically permits: a naked singularity, a point of infinite density not hidden behind an event horizon, exposed to the external universe. All four alternatives: same photograph, same stellar orbits, same Nobel Prize-worthy discovery, different physics inside. In 2024, the gravity instrument at the Very Large Telescope Interferometer in Chile, combining the light of 4 8-meter telescopes to achieve 4 times better resolution than any previous galactic center measurement, published a detailed analysis of the orbital behavior of stars near Sagittarius A. The paper found something subtle. The detailed shape of S2's orbit at closest approach shows a statistical preference for a compact object with a slightly extended mass distribution rather than a point-like singularity. The effect is small. The statistical significance is not conclusive. It could be explained by gas or dust near the galactic center rather than the internal structure of the object. But the authors stated explicitly, these are people who have spent their careers studying the galactic center, that the data does not rule out alternatives to a black hole. That is a significant statement, and it connects directly to the information paradox, the problem Stephen Hawking identified in 1976 that has never been resolved. What happens to quantum information that falls into a black hole? General relativity says it is destroyed. Quantum mechanics says information cannot be destroyed. The two most successful theories in physics directly contradict each other on this point. If Sagittarius A star is a boson star, the information paradox disappears. There is no event horizon, no singularity. Information is not destroyed because nothing is trapped. Quantum mechanics and general relativity both survive, two of the deepest unsolved problems in physics. Dark matter and the information paradox, resolved by discovering what actually sits at the center of our galaxy. The next generation, an event Lala Horizon Telescope, currently being planned with additional telescope sites and higher radio frequencies, will be sensitive enough to measure the photon ring substructure of Sagittarius A star. A boson star produces concentric subrings at specific angular separations. A true black hole does not. The measurement is within reach. Sagittarius, a star, is 26,000 light years away, but it is not distant in any meaningful sense. It is the gravitational center of everything you have ever known. Every star you can see on a clear night is orbiting it. Our sun is orbiting it right now at 514,000 miles per hour. As we covered in our last video, you are moving at over 1 million miles per hour, and a significant fraction of that speed is your orbit around whatever sits at the galactic center. Everything, every civilization, every human life, every moment of Earth's 4 billion year history, orbiting something we photographed in 2022 and still cannot identify. We called it a black hole because that was the most natural explanation, the most parsimonious, the most consistent with the physics we know. But the photograph does not confirm it. The Nobel Prize does not confirm it. The stellar orbits do not confirm it. They are all consistent with it. Consistent with is not the same as confirmed, and in that gap between consistent with and confirmed sits one of the most consequential unanswered questions in modern physics. What is at the center of our galaxy? What we are all orbiting, what the Milky Way has been rotating around for its entire 13 billion year existence. We have an image. We just do not know what we are looking at. If that unsettles you, it should. And if you want to go deeper on the dark matter and dark energy connections we mentioned, we have full documentaries on both already on this channel. Links in the description. The subscribe button is directly below this video right now. Hit it, and I will see you in the next one.